Today we're going to prove that we can prove sides and angles and diagonals congruent using properties of parallelograms, and then we're going to use the converse, use the properties to prove that shapes are parallelograms. So these four theorems are just based on the characteristics we learned yesterday. If a figure is a parallelogram, then opposite sides are congruent. If a figure is a parallelogram, then opposite angles are congruent. If a figure is a parallelogram, then consecutive angles are supplementary. And if the quadrilateral is a parallelogram, then diagonals bisect each other. Okay, we can use those in proof. So here's my picture. We're given that ABCD is a parallelogram, so all the characteristics apply. We want to prove that BAD is congruent to DCB and that ABC is congruent to CDA. So we're looking at opposite angles being congruent. Okay, so we're given that it's a parallelogram, which means the pure definition of a parallelogram is that AB is parallel to CD and that BC is parallel to AD. So that's a definition of a parallelogram. Okay? All right. Then we've got the alternate interior angle theorem. Well, if I've got parallel lines, they're cut with transversals. So the diagonals become the transversals. So that means if I start at the upper left corner, angle ABD is congruent to angle CDB. Okay, and angle CBD is congruent to angle BDA. I'm kind of color-coded them. Can you see? So I just did ABD and this angle, BDC. So these two are congruent. Then I did CBD and BDA. Those are congruent. Okay, and then I do the other two, the A corner and the C corner. So angle CAB is congruent to its alternate exterior, which is ACD. And the final one, BAC, is congruent to angle ACB. Because all of those are alternate interior angles. So we got this one's congruent to this one, and this one's congruent to that one. Alternate interiors. Okay? Then the reflexive property, because we're trying to prove again, now look at this step down here, we're trying to prove that triangles are congruent. So the reflexive property are going to be those diagonals. We're going to say that AEC, or that line AC is congruent to AC, and BD is congruent to BD. So basically we're just identifying the diagonals, because this diagonal is going to be a side of these two triangles, and this diagonal AC is going to be that side of the triangles going the other way. So then I have, the next step is triangle ACD. So that's ACD, that's this triangle, is congruent to CAB. That's this triangle. Okay? And I have this side is congruent to itself because of the reflexive property. And then I have this angle is equal to that angle, and this angle is equal to this angle. So by angle, side, angle, I have the triangles are congruent. Okay? Same thing with BDC and DBA. BDC is this triangle, and BDA is this triangle. So again, this side is congruent, so we've got angle, side, angle. Okay? Now, once I have the triangles are congruent, then pieces of those triangles are congruent by CPCTC. And so we've just proved that the opposite angles, this angle and this angle are congruent, and this angle and this angle are congruent. Opposite angles of a parallelogram are congruent. All right, and then the converse is also true. If you have a quadrilateral with opposite sides congruent, then it's a parallelogram. If you have a quadrilateral with opposite angles congruent, then it's a parallelogram. If you have a quadrilateral with congruent supplementary angles, the consecutive angles are supplementary, then you have a parallelogram. And if you have a quadrilateral whose diagonals bisect each other, then you have a parallelogram. And we're going to add one more, this very first one up here. If a quadrilateral has one set of equal and parallel sides, then it's a parallelogram. So all the others said, if opposite sides are parallel, or if opposite sides are congruent, okay? But this first one says if one set of sides is both. So if these two are congruent and parallel, then that shape is a parallelogram. Okay? So we go through here, are they a parallelogram? Well, if they're a parallel, if we can prove that these consecutive angles are supplementary, then it would be a parallelogram. And since 107 plus 73 is 180, yes, it's a parallelogram. Okay? This one has one set of parallel sides and one set of congruent sides, but they're not the same size. So we cannot verify that that's a parallelogram. If the congruent symbols were with the parallel symbols, then it would be yes, that'd be a different story, but they're not. Okay? In this one, we have diagonals that bisect each other because this side's equal to this side and this side's equal to that side, so yes. Here, we do have one set of parallel sides and congruent sides, so it is a parallelogram. Okay, and here we have opposite angles congruent, right? 35 and 35, they're congruent. These two are marked congruent, so since opposite sides are congruent. All right, so you need to, again, we said this yesterday, it's so important to know these characteristics. They have supplementary consecutive angles, but the diagonals bisect each other. Opposite angles are congruent, opposite sides are congruent. And if opposite sides are, if one set of sides is parallel and congruent, we're going to add that to say that it's a parallelogram. All right, and then we have one more kind of proof to do with parallelograms. That is, we're going to prove that ABCD is a quadrilateral. Actually, I think that should say ABCD is a parallelogram using the fact that quadrilaterals with a pair of opposite sides or parallel is congruent. Okay, so this is like the converse. We learned that if it's a parallelogram, then opposite sides are parallel. Well, we're going to use the converse. If opposite sides are parallel, then it's a parallelogram. So the first thing I have to do is graph my shape. So I have A, 6B, C, and D. So here's my parallelogram. Okay, and I just have to prove that the opposite sides are parallel. So in a coordinate proof, the way I do that is I show, to prove something's parallel, you just have to show they have the same slope. So I'm going to find the slope of AB and the slope of DC. So A starts here, and you go down 1, 1, 2, 3, 4, over 4. So down 1, over 4. DC is down 1, 1, 2, 3, 4. Oops. 1, 2, 3, 4, 5. Did I miscount that? Yeah, I didn't graph C correctly. C is here at 5. You probably were yelling at me on the tape that I messed that up. Okay, so that's C. So it's down 1 and over 1, 2, 3, 4. Okay? So it has the same slope. Therefore, that those little dots, remember, mean therefore, AB is parallel to DC. Okay, then when I do the other two, I need the slope of AD and the slope of CB. CB is up 2 over 1, and DA is up 2 over 1. So those also have the same slope. Therefore, AD is parallel to CB. All right? And so I can say that quadrilateral ABCD is a parallelogram by converse of parallelograms have opposite sides parallel. Or this is the written out converse. And you can do either one. Okay? And that's what we're going to do today. Prove with regular proof, prove with coordinate proof, and identify just the characteristics.